This presentation will overview Josh Binsler's capstone project, which is the implementation of Vogel's quality management system and the ISO 9001 program at the Fosse Paint Industrial and Aerosol divisions. My project scope started as an ISO 9001 and Vogel quality management system implementation. This included the planning phase, the implementation phase, and the maintenance phase. During the planning phase, while checking the manufacturing procedures and defining what these manufacturing procedures are, we had to find tolerances that each procedure had to fall within. During that process, we found an error or an issue in one of our manufacturing phases. This led to a scope shift. This shift actually changed the scope from the implementation of ISO 9001 to the aerosol line being modified so that the aerosol line procedures would be aligning with the ISO 9001 and Vogel quality management system implementation. The new project scope required the modification of our current aerosol line by rearranging equipment on that aerosol line. Now we would have a planning phase, an implementation phase, a review and test phase for the aerosol line modification. I want to take a step back and look at what ISO 9001 and Vogel quality management systems are. They are a set of management standards governing quality assurance. They provide framework for systematic approach to process management. They require detailed accounting of procedures and work. They include documenting that process for how the company designs, produces, inspects, packages, and installs product. Inevitably, it's the management of process and the continual process improvement. This process requires Fosse Paint to define what does quality mean in their organization. The Vogel senior management team has come up with a quality definition that reads, the totality of features and characteristics of a product or service that bears on its ability to satisfy given needs. This means that the quality of a product is only relational to the perspective and what the subjective views of our customers are. A customer pays a certain dollar amount and expects that certain dollar amount of quality given. In a nutshell, when you overview the entire ISO 9001 and Vogel quality management system, it is broken down to say what you do what you said you do, and prove that you did what you said you did. This means that you have to define what you do as a manufacturing company, manufacture the way you said you manufactured, and then prove to someone that you did through quality checks and quality assurances. The benefits of an ISO 9001 program are to really improve the quality of the product and the process. This makes the process consistent and it makes it more efficient. Consistency equals efficiency when it comes to manufacturing. It streamlines and reduces inefficient processes by identifying inefficient processes or processes that don't lead to quality product. It also adds a legitimacy to our quality. This legitimacy is in the form of being able to prove to people that the product they are receiving meets a certain standard and requirement, whether it's self-imposed or government-imposed. It also adds value to our customers because it adds a framework for growth. We can give them different quality sections and say we can appraise value to this quality section at this. If a customer is looking to improve quality or look for different characteristics, we can offer consistency in a different price point. It also approves accountability. This shows that each person doing their job is doing their job. If the work is being done correctly, the product should fall within a certain spec, and we don't have to worry about issues being swept under the rug. It also creates a better working environment. Employees do not have the questions that they previously had because they have a strict understanding of what their job is, what the job requirements are, and the tolerances in which their job should be completed. The initial project scope was to compare current processes to the ISO 9001 standards, evaluate the discrepancy, compare the current processes to Vogel quality management system standards, and then evaluate that discrepancy. The Vogel quality management standards are slightly more stringent and more inclusive than the ISO 9001 standards. Vogel took it upon themselves to hold themselves to a higher standard and create a program that would reflect upon that so our customers can see that we are doing everything in our power to make a quality product. During the ISO 9001 and Vogel Quality Management System process of defining what our process is, the procedures around our process in our aerosol department, we uncovered an issue with our gaskets that are used within our tippers and our valves. An aerosol manufacturing procedure that requires us to run a finished can through a hot water bath was causing the gasket to swell. What we were running into is an inconsistent spray tip depth when the tip was being inserted into the valve stem. I will go over these resulting issues, what causes this issue, and some of the solutions to this issue. The results of the improper tip depth is defective aerosols. The spray tip itself was damaging the gasket. When it was manufactured, the cans would not leak. The damage occurred when the end user would depress the tip in, and it would take a small gouge out of the gasket. This would not allow that gasket to properly seal around the spray tip stem, and paint would leak out around the base of the tip, as seen in the photos. The main cause of this issue is improper tip depth. The reason we could not hold consistent tip depth is because we were inserting the spray tip after our hot water bath. First of all, we have to look at why the gasket was swelling. The gasket swells in the hot water bath. The reason that gasket swells in the hot water bath is because solvents in the paint swell a neoprene gasket. The neoprene gasket is designed to swell. The reason it swells is so that it can seal around the stem of the tip. The issue with the hot water bath and trying to insert the tip after that is the hot water bath increases the rate of swelling that occurs on this neoprene gasket. The DOT requires the hot water bath of all finished aerosol products. It's a requirement in order to ship over roads or national highways. It is a simulated test to simulate an aerosol being stuck in the Mojave Desert on a train car for 3 days. A test was done that put aerosols in a train car in the Mojave Desert for 3 days, and the max temperature that it reached was 127 degrees Fahrenheit. That means that they added a small fudge factor, allowing for a safety factor, and made that the rule. So each aerosol has to reach equilibrium, which means by the ideal gas law that the rate of evaporation inside of a pressurized vessel equals the rate of condensation inside of that pressurized vessel. As the temperature is increased, the rate of evaporation must increase, and also the rate of condensation must increase. So the improper tip depth is manifested itself when the tip is trying to be inserted after the gasket is swelled at a mechanical tipper. The original spray tip outside diameter is 135 thousandths. The gasket before the hot water bath is 139 thousandths. This is not an interfered fit, and the tip should be inserted into the gasket relatively easily. The problem is the gasket ID after the hot water bath shrinks to about 129 thousandths. This creates an interference fit between the spray tip and the valve stem gasket. The tipper is not designed for an interference fit because if you use too much pressure to insert the tip, it will cause the aerosol to spray inside of the tipper, which causes downtime and increases manufacturing costs. So what's the solution? The simple solution is to move the tipper before the hot water bath. As you can see in the picture, this shows the tipper to the left with the red arrow. It shows a yellow checkware, which weighs the can, a blue accumulation table, and then a water bath, which is our 24-foot 4-lane water bath. Moving into the planning phase for this aerosol line modification, we have to look at what work is required and who is going to do these works. Our contractors that we're going to need are HVAC services. We have some ventilation ducting that needs to be disconnected and reconnected. We have Edgewater plumbing because of a boiler system that needs to be drained out, piping redone and rehooked up. We also have a water line that needs to be moved and 2 drain lines. Cons Electric has to unhook all of the electric pieces and parts on our machinery and our aerosol line, move the electric drops to their new location, and then reconnect all of our equipment. Vogel's maintenance is going to be a part of this project because they're going to be coming down to lend a helping hand. We will have 3 of their employees that will come down the week of the 4th through the 8th and help us move and set up. This is to alleviate costs, not to have a contractor come in and do all of the work. Fossey employees, because one of the aerosol lines will be down and we will have 4 employees with no work to do, will be also assisting in this. 2 of the employees will actually be helping out on our other aerosol line to add efficiencies to that line, while we're taking 2 of our more mechanically inclined employees and adding them to the work that is going to be done on our first line. Our budget has to be developed, which means that each contractor will have to come to our facility. We'll have to give them what their jobs are, what their task is, tell them when we need them here, and what material they will have to order. Vogel, their maintenance staff, will have to pay their wages. We'll have to pay the time that it takes them to get down here. We'll have to have hotels, meals, and other accommodations. And the Fossey paint employees will be their standard work rate, as they will be doing their standard work hours. The second part of the planning phase is we got to develop a timeline. We have to know what we're going to be doing, so we're going to start off with developing the new layout as configured into a AutoCAD and dimensioned. We also need to inform our contractors of the project, ask for some pricing, ask for availability and a willingness to be a part of this project. Once it gets to March 7th through the 8th, the Vogel team flew in. We went over the project, laid out on the warehouse floor the new locations, went over, developed a detailed list. Contractors were decided, tools lists were decided, tasks were assigned to each group and contractor. Each task was assigned a priority level and a date required for completion. All the dimensions were verified, the machinery was labeled, and the project scope was extremely detailed, written down so that there was no questions and people knew what their tasks were. On March 28th, we had a project review meeting to go over the status of all the contractors, tools, materials, and any new potential issues that people had come up with. The implementation phase actually begins this Friday, as Next Gen Coatings and Cons Electric and Edgewater will begin starting with some of the required pre-work, disconnecting, shutting off, draining, taking off tracking conveyor, some of the easier parts that we can do, so that Monday, when the Vogel's maintenance team shows up and all the other contractors are here, we can work together to get things done more efficiently, reducing the time and cost for having contractors on site. After the complete rearrange is done and the task lists have been completed, we will begin testing the new aerosol layout, and by doing so we're going to start with 100 aerosol cans using just a cleaning solvent, nothing that we can throw away, that if it's not correct or it gets damaged doesn't cost the company a lot of raw material cost. But after that, and we get into the initial testing, we check transfers, we figure out if the layout's going to work properly and devise new additions to this layout if there are issues. We will continue to hone and work this process by reviewing and testing throughout the month of April. After we complete this, then we can begin working on the ISO 9001 and Vogel Quality Management System program that we had initially started implementing. So, when we get into the implementation phase, the task requirement check sheet, each contractor was given a specific list of tasks that they were commissioned with. Each contractor is made aware of what they have to do and will report back after the task is completed to the project manager on site, Josh Binsler. Vogel maintenance and Fossey employees will also have task check sheets that they can report back to Josh. He will have a master list that shows where we are within the process, making sure that each project and task is being done on time and on schedule according to the check sheet. The reviewing and testing phase tests the new aerosol line out, confirm layout dimensions, build or develop as-built drawings so that we have a true record of what we have set up in our facility at this time. We will confirm that by adjusting the tipper before the water bath, we can hold a proper tip depth. We will test conveyor transfers, as the transfers are the largest hiccup or sticking point in the aerosol manufacturers. Poor transfers can lead to can backs up and damaged goods. And then from there we'll begin running production, starting with pre-charged aerosols, cleaner aerosols with no paint, low cost, and if damaged goods do occur, it won't be of high value to the company. Next, we will move into low-cost paint production, which is low-dollar paint that we manufacture at our facility and not customer paint. After we get through that and we feel comfortable enough with the aerosol line and its manufacturing process right now, we will move towards the normal production of all the paints that we receive from customers, as well as paint that we manufacture in our facility. This process overviews the entirety of the project, and this project, once completed, will allow Bossy Paint to get back into the ISO 9001 and Vogel quality management system that this project originally started as. The project of the ISO 9001 implementation typically takes about 4 months, but because of this issue, we have added about 2 to 3 months to that original 4 months, and barring any other issues, we should be able to get this done over the next 2.5 to 3 months.